Hello, boys and girls. Welcome to the Dow Academy Online Learning. We look forward to seeing you all back in class. But for now, stay home, stay safe, and remember to always wash your hands with soap for at least 20 seconds. Let's begin.
Yes, morning. We meet again for lesson number 4 on electromagnetic effects, but we are now looking at the transformer. Remember, we started this story looking at electromagnetic induction and all these are its applications. Right, the transformer, a very useful gadget that we have around. We have seen them in the streets on poles there with a green box up there where there are electric lines. That is the transformer there. A transformer is a device which is used to vary the voltage of an AC supply. By varying here we are saying either to increase the voltage or to decrease the voltage. Let's say you've got a gadget which you want to use this other side and it requires a high voltage. You need to increase that voltage. You start with a low voltage, then you increase. Or you want to use a low voltage this side. It means you start with a high voltage, then you decrease. So varying is either increasing the voltage or decreasing the voltage. Let's look at the structure of a transformer. If we break a transformer and look at it inside, we've got this representation. We've got a soft iron core. This is a soft iron core, and we have got a coil which you call the primary coil this side, which is to your left side. Then to your right side we have got the secondary coil, and this is where you connect your gadget that you are using. It can be a cell phone charger, it can be a light or anything that you connect there. So our input voltage is this side. That's why we're calling it VP, meaning primary voltage, giving us a primary current, and NP. NP is showing the number of turns in the primary coil. You are not going to count them, but you be given the number or you are required to calculate them. Right? Then we've got this part here where you're supposed to label all the symbols shown. So I want you to draw the diagram. Below the diagram, you label what is VP, what is IP. Like I've already said, VP is primary voltage, primary current or input current. Then you continue. How does a transformer work? The working principle of a transformer is what you call the mutual induction. Mutual induction. What is happening here? We are saying an alternating current in the primary coil here sets up or it creates a changing magnetic field. When current comes here and interacts with this soft iron core here, a magnetic field is produced here. And that magnetic field, as it spreads out, spread out, it will interact with another coil this side, the secondary coil. And we have an EMF being induced and a current being induced. So we are saying an alternating current in the primary coil sets up a changing magnetic field which induces an alternating EMF, Vs, secondary voltage, in the secondary coil. Types of transformers. We've got two types of transformers. We've got a step-up transformer which increases voltage. Means you give it a low voltage, then it gives you a high voltage this side. It steps up the voltage. How are you going to identify a step-up transformer? The number of turns on the secondary coil is higher than the primary coil. Voltage, output voltage, Vs, is higher than Vp. That's a step-up transformer. So I want you to do the same thing for a step-down transformer. What will be happening in a step-down? Already it's clear. It is clear there, it decreases the voltage. Right, you are going to get questions on calculations on transformers. When you are calculating using transformers, we are using what you call a 100% efficient transformer. Meaning the input power equals the output power. Input power equals output power. We are assuming there are no energy losses. Whatever you give it, this side is equal to what it produces this side. So the first equation you have there is power in equals to power out. We've done power, you know the equations for power. voltage times current equals to voltage times current. The second equation is shown here, Vs over Vp equals to Ip over Is. You can use this one if you are given these components. Then we also have the other one here, Vs over Vp equals Ls over Ip equals this. What you are going to do, you are not going to use all the three of them. You use only two. Either you pick this component only, Vs, Vp, Ns, Np, you use that. So it depends on the question. Or you can use V and Ip, these two. You only use two ratios at a time. We've got a worked example there, which is given here. A 240-volt transformer is transforming, voltage is transformed to 12 volts AC for a model railway. The primary coil is 1000 turns. Part A of the question, state the type of transformer. From this given information, you should be able to identify what type of a transformer is this. Right? You look at the voltage given from 240 to 12. It is decreasing. So already we are saying under solutions here, this is a step down transformer. It decreases the voltage. Then you are required to go to part B. How many turns should be on the secondary coil? And we are saying you are going to use this equation or this ratio. The one with voltage and the one with number of turns. You ignore this one for current because we don't have current values in your calculation. You only have these ones. So you concentrate on that. Substitute into your formula. You cross multiply, divide. Final answer here, 50 turns. Already showing that this is a step down transformer from 1000 turns to 50 turns. Then it steps down. So move on to read on transformers. There's a lot here. We'll see it as you read on. Then this is a short exercise which you have to go through. Make sure you write it clearly. I'll have to check it and look at it later on. Page 302, 304, following questions. Otherwise, thank you. Stay well, stay safe.